systems architecture or home care, cloud application and service IoT system. Dr. William S. Chow is the president of Association of Enterprise Architects, Taiwan chapter. Chapter 1. What is home care IoT system? A cloud app and service IoT system is a network of physical objects embedded with electronics, software, sensor, and connectivity to enable it to achieve greater value and service by exchanging data with the user, operators, and other connected devices, as shown in Figure -1. A generic cloud application and service IoT system can also be generally represented by the following framework, as shown in Figure 1-2. There are 3 layers appear in Figure 1-2: application layer, data layer, and technology layer. Behavior of home care cloud app service IoT system, abbreviated HCCA-SIS, consists of the following 5 behaviors. Behavior of registering home account. Each home needs to register to HCCA-SIS to get the home care application and service, as shown in Figure 1-3. Since HCCA system allows more than one senior resident to be monitored in a house, all names of senior residents should be registered accordingly. The second behavior is sensing resident positions. At regular intervals of 10 to 15 seconds, the position sensor will be sensing the position of each senior resident at home. The position of a resident is specified by the 3-dimensional location data of that person's geometric center, as shown in Figure 1-4. If there are more than one resident in a house, then more than one position will be sensed. The third behavior, alert notifying. By constantly analyzing the 3-dimensional location data, which is recorded in every 15 to 20 seconds, the movement and location of each senior resident shall be determined if there is any abnormal situation. Typical situation that an alert will be triggered, as shown in Figure 1-5 are: a resident fall on the floor for more than a certain amount of time, or B, a resident has irregular movement pattern, or C, a resident shows a significant lack of movement. The fourth behavior is recording emergency responses. If there are abnormal movement and location, alert will be displayed on the screen for home care provider to take an emergency response. Once the emergency response has been completed, home care provider should record it on HCCA, as shown in Figure 1-7. The last behavior, printing monthly statistics. The aim of monthly statistics report is to furnish home care provider with the latest available home care statistics, as shown in Figure 1-9. Chapter 2. What is SBC architecture? Generally, a system with very intricate that it includes many views, such as data, structure, function, behavior, and so on. There are two different ways to model such many views. The model multiplicity approach, such as Unified Modeling Language (UML), separately pick a model for each view, as shown in Figure 2-5. The model singularity approach, instead of choosing many unassociated models, will use only one integrated model, as shown in Figure 2-6. Structural Behavior Correlations (SBC) means to integrate the system structure and system behavior. SBC architecture uses 6 fundamental diagrams to describe a system. These diagrams are shown in Figure 2-20 are architectural hierarchy diagram, B, framework diagram, C, component operation diagram, D, component connection diagram, E, structural behavior correlations diagram, F, interaction flow diagram. SBC architecture is a model singularity approach as shown in Figure 2-27. Chapter 6 Framework Diagram of HCC Axis. Framework Diagram FD depicts the structural view of a system. Figure 6-1 shows the FD of the home care application and service IoT system. In Figure 6-1, presentation layer contains the home account registering UI, alert notifying UI, emergency response UI, and monthly statistics UI component. Logic layer contains the sensor data acquisition daemon component. Data layer contains the HCC Axis database component. Technology layer contains the position sensor A0001, position sensor A000002, position sensor Z99999 components. Chapter 7 Component Operation Diagram of HCC Axis. Component Operation Diagram COD depicts the structural view of a system. Figure 7-1 shows the COD of the home care cloud apps and the service IoT system. In Figure 7-1, there are totally 7 components, but we only show 3 components and their operations. Component home account registering UI has 1 operation, that is input home data. Component alert notifying UI has 2 operations. They are showing all alerts and displaying alerts. Component emergency responses UI has 1 operation, that is input emergency responses. Chapter 10 Interaction Flow Diagram of HCC Axis. Interaction Flow Diagrams IFD depicts the behavior view of a system. HCC Axis includes 5 individual behaviors. Each individual behavior is represented by an execution path. We use an IFD to define each one of these execution paths. Figure 10-1 shows an IFD of the returning home account behavior. There are two interactions in this IFD. The first interaction is between the home care provider actor and the home account returning UI component. The second interaction is between the home account returning UI component and the HCC A6 database component. Figure 10-2 shows an IFD of the sensing resident position behavior. In this IFD, there are four interactions. The first interaction is between the server root actor and the sensor data acquisition daemon component. The second interaction is between the senior residence actor and the position sensor end component. The third interaction is between the sensor data acquisition daemon component and the position sensor end component. The fourth interaction is between the sensor data acquisition daemon component and the HCC A6 database component. Figure 10-3 shows an IFD of alert notifying behavior. In this IFD, there are three interactions. The first interaction is between the 1-minute interval actor and the alert notifying UI component. The second interaction is between the alert notifying UI component and the HCC A6 database component. The third interaction is between the home care provider actor and the alert notifying UI component. Figure 10-4 shows an IFD of the recording emergency responses behavior. There are two interactions in this IFD. The first interaction is between the home care provider actor and the emergency response UI component. The second interaction is between the emergency responses UI component and the HCC A6 database component. Figure 10-5 shows an IFD of the printing monthly statistics behavior. In this IFD, there are three interactions. The first interaction is between the home care provider actor and the monthly statistics UI component. The second interaction is between the monthly statistics UI component and the HCC A6 database component. The last one, the third interaction, is between the home care provider interact with the monthly statistics UI component. The third interaction uses the same operation with the first interaction. All these operations are provided by the monthly statistics UI component. Here we have some advertisement. Actually, if you are interested in finding out more material of this talk, you can go to the Amazon bookstore to get this book. The URL is shown on this page. Actually, the book name called System Architecture of Home Care Cloud Application and Service IoT System, written by Dr. William Chow. There are both Kindle version and paperback version as well. Hope you will like to read in more detail of this book. At last, we thank you for your patiently listening to this talk by Dr. William S. Chow. If you have any question, please email me Also, you can go to view our website as shown in this page. Thank you. See you all next time. Bye bye.